So let's look at another example. So for the function f of x equals 2 times 1 over 3 to the power of x plus 4. So just by identifying the base being 1 over 3, we can say that this is going to be a decaying exponential function because our b values between 0 and 1. Is this an exponential function? How can you tell? So this is an exponential function because our variable is in the exponent. Is this growth or decay? We identified earlier that this is a decay because our base of 1 over 3 is between the values of 0 and 1. What is the value of the y-intercept? So it's asking us where the graph crosses the y-axis. And we know that we can calculate that if we set x to 0. So if we were to substitute that into our equation, we can determine our y value. So f of 0 equals 2, 1 over 3 to the power of 0 plus 4. Exponent laws, anything to the power of 0 is 1. So 2 to the power of 1 plus 4. We continue simplifying. 2 times 1 is 2, plus 4 is 6. Therefore, but the y-intercept is 6. Okay, if you want to write our point, this would occur at 0, 6. So what is the equation of the horizontal asymptote? So remembering that the horizontal asymptote is where the graph doesn't cross this axis. This occurs at 4 in this question. Let me explain. This is a form of a transformation. And in this position, the graph is being transformed up 4 units. So rather with our original exponential functions, where it was just the base and the exponent, this value is 0, in which we saw our graph did not cross x equals 0, the horizontal axis. But in this case, because there is a vertical transformation, that this equation or this graph will have a horizontal asymptote at 4. So let's sketch. Okay, we have some very important pieces of information. Let's state our intervals. So this is our x-axis, this is our y. We said this is 1, 2, 3, 4, 5, 6, this being 0. We have a point knowing that our y-intercept is at 6, so we can plot that here. We also know that we have a horizontal asymptote at 4, so we can draw a dotted line as our asymptote. X equals 4. Just to note there. I cannot spell. Therefore, knowing that this graph is a decay, we can sketch it going downwards. So we're going to start high and the graph curves down. State the domain and range as our final step. So the domain looks at the horizontal axis. So where does the graph exist along X? And in this case, we can find a point for every X value. If we continue this graph, we can still find X. If we continue this graph upwards, there still will be a value of X. So therefore, our domain equals X is an element of real numbers. If we look to our range, which is looking where our graph exists along the y-axis, well, we can see that our graph cannot go below 4. So that's our restriction. So y is an element of real numbers such that y must be greater than 4. The graph does not exist lower than 4, so that is our restriction.